So our next presenter, Adam, I have to give George a shout out and a thank you for introducing me to Adam. Just hearing about, again, just another perspective of CTE and how they're bringing it, another model, another example. Again, that's what this is about. It's about learning from different ideas and then figuring out how you can adapt and make this work within your school. So Adam, come on up and take it away. And yes, poor Adam is between us and lunch right now, so no pressure.
No pressure at all. Yeah, thanks. Whew. Yeah, nothing like adding a little. Yeah, CJ laid that on a little thick. Thanks, bud. Really appreciate that. No, I'm incredibly excited to be invited to speak to everyone here as a former classroom teacher, a curriculum writer, a curriculum director, an assistant superintendent. Being in a room of so many educators that feel so deeply about what we're doing, what we're trying to accomplish it's energizing. And I just want to thank you for all the hard work that you do on a daily basis, because you're molding our present and our future. And so thank you, for this opportunity to chat. So can I have yep, perfect. I want you to look at this number. Am I okay? Like, is the mic picking me up? I didn't put yeah, perfect. Look at that number for a moment. Breathe that number in. It's a big number. That is a lot of zeros. There are 12 zeros there. The reality is this. This is an incredible problem that we need to figure out how to solve. That's funny, I lost all my notes. We're gonna go without notes. This is a problem that we have to figure out. But before we do, I'd like to just quickly introduce myself. My name is Adam Couturier. I'm the Director of Manufacturing Education at the MASSTech Collaborative. Basically, what the MASSTech Collaborative is, it's an organization that exists because of Massachusetts state general law. We exist as an economic driver for the Commonwealth, especially around next generation technologies. We exist to help figure out how we're going to bring things to scale. And out of our group, there's 5 divisions, and I'm from the Center for Advanced Manufacturing, but we run the state cybersecurity division. We have DigiHealth, we do all sorts of different things around innovation. And our job, our goal, especially at the Center for Advanced Manufacturing, or as we like to just use acronyms and say CAM, is that we want to help our manufacturers from an idea that is sparked all the way to production so that they can be successful. Because we realize that by supporting the industries in our state, well, that's only going to help raise the tide for everybody. But that also kind of brings up some issues that we have. We need a workforce. Something happened, and I want to go back to that $1 trillion number. But one of the things that happened during COVID is we saw, and we all have COVID stories, I know, but it did change everything. And it maybe shined a flashlight on issues that were kind of long in the making. One particular area that I know has been dramatically impacted was the production of semiconductors. You might have remembered, during the height of COVID, these massive fleets of Ford F-150s that were just sitting, unable to be driven off the parking lot because they didn't have semiconductors inside of them. The brains, unfortunately, aren't really in large numbers produced here in the United States. They were overseas, but we weren't necessarily open to bringing things in at this particular point in our history. So this global semiconductor value and supply chain is completely disrupted. At the same time, there's an increase in demand. My refrigerator has semiconductors in it. I have a smart refrigerator. Why? I don't know, but I have one, and you probably do too. All of a sudden, from our cell phones to our tablets to our computers, and yes, to the fridge, needs these microelectronics, these brains to get things rolling. But really, from the 80s, continuing today, we shipped a lot of that production overseas. As a result, currently in the US, we only make 10% of the semiconductors that power things like our phones and our cars and our appliances. And that's just really one industry. This is just one example. You could explore this and multiply it out. George has some great data sets on this. I mean, for instance, in the US, we make even less batteries than we do semiconductors. Think about how much is powered by a battery. We have a significant challenge before us that we have to do something about. There's these unprecedented investments that are being made at the federal level to reshore and create the next generation of technologies. And this is fantastic. This is good news. However, you need people to be able to do these jobs, to create these things, to make these things, to use this technology. And do we have a robust system that can actually respond to reshoring all of these industries back into the US? Right now in Massachusetts, there's currently 14,000 job openings in manufacturing, just in Massachusetts. And these numbers are projected to increase in the next 5 years as folks, I don't know if it's affectionately or not, referred to as the gray tsunami. As folks are retiring from these jobs, there's not necessarily enough folks to fill these vacant slots. There's an estimated that 2.1 million US manufacturing jobs will go unfilled by 2030. And that is from the National Association of Manufacturing. And this is the crazy thing. That number is the anticipated loss that is associated with all of those unfilled jobs. So we have a $1 trillion problem before us in a sector, manufacturing, advanced manufacturing. And the reality is, we don't necessarily have robust systems to take care of this. Now, I'm going to speak a little bit about Massachusetts, but I follow enough of national trends to know that this is not unique to Massachusetts alone. Our vocational technical schools are oversubscribed. Again, I can say that without a doubt for Massachusetts. The wait lists to get into these schools are astronomical. It's an issue. We don't have enough graduating students that are actually entering the industry. And again, speaking for Massachusetts, our community college system, the programs that we have aren't doing the best as far as numbers. And that's also taken a hit since COVID, as our community college enrollment nationally is down. We don't have the programs, at least in our state, to meet that demand. And so what I wanted to do was talk a little bit about what we're doing to try to solve this problem. And so with that, funny, I like this video. I've done this once before. I love watching people's faces because they're incredibly confused. You're like, I thought we were talking about advanced manufacturing. The reality is I just really like nature videos and I wanted to share them with you. But no, but what I love about this boggles my mind, right? Legitimately, that they took 14 wolves, introduced them into an ecosystem, and then the ramifications, almost like you're skipping a rock across a lake, ripples, right? So the fact that the deer population starts thinning out, and as a result of that, flora and fauna are popping up, insects are coming in, birds are coming in. Now you have all these mice and hawks and birds of prey, and literally, this loose alluvial soil now firms up, changing the very trajectory of the river. What I like about this video, and I know it's a silly way in, but it's an analogy for me. The reality is, one decision can move rivers. And I'm obviously giving you a case study of what we're trying to do in Massachusetts to address this $1 trillion problem. But the reality is the brain power in this room can make decisions in your local environment to change the very trajectory of our young people's futures. It's an awesome responsibility that's placed before us. One decision can move rivers, one decision can change everything. So what is Massachusetts doing about this talent shortage in advanced manufacturing? So this is just what we're doing, and maybe there's some things we can borrow. I mean, I've been to WestMech with CJ's operation, and I love what's going on over there, and there's things that I definitely want to continue to take from that group. But what can we learn together? And so I'll tell you what we're doing. One of the things in Massachusetts is we realized the aperture of the talent pipeline is too constrictive. That we had to figure out a mechanism to open up that aperture because not enough students are getting through that talent pipeline to fill this demand that is going to have national ramifications if we don't. Not just fiscally, but for our own national security. And so in order to open up that aperture, we looked at creating sort of an alternative pathway. And so we're calling them innovation pathways. And so it's really looking, I can't take credit for the content of these two slides. I stole this from the Southern Regional Education Board probably 5 or 6 years ago. I thought it was great, and I've used it ever since. But we're moving away from this dichotomy of like, hey, you got the college track, and CJ, you kind of brought that up, right? You got the college track, and then you got the career track, and never the twain shall meet. This is a problematic approach for a variety of reasons. Higher ed is more expensive, the entry point is difficult, and so we're trying to switch that narrative and move this into this idea of advanced career training so that every kid in high school has access to career technical training, that they have an opportunity through these STEM applied careers, they can see themselves in this future where they're bouncing around and they're getting training at different points. It's much more dynamic than this old two-system kind of route. And so our innovation pathways function this way. They're designed to give students coursework in advanced, my case is advanced manufacturing. We have this in healthcare and IT and so on and so forth. But again, I'm from the Center for Advanced Manufacturing, so it makes sense that that's the test case I'm using. But we have these programs that are applied STEM programs, and in this case, advanced manufacturing, where we give them coursework in design and engineering and so on and so forth, and we provide hands-on experience and college credit. So part of this designation process set up by our Executive Office of Education is that you have to be able to come in and basically, do I have this on the slide? I'm going with that just from memory, so nope, I don't have it here. So this is essentially what it is. You need 2 industry-aligned courses. You need 2 college-level courses. Part of this is we want to have kids be empowered by options. And then at the same time, as George was mentioning about this idea of industry-recognized credentials, the Department of Elementary and Secondary Ed is tracking industry-recognized credentials. In fact, really fantastic news for us as a state. Back in, it was April of last year, our legislature passed a $750 per pupil funding source for IRCs related to manufacturing and green technology. And now this is another way schools can use these funds to power their programs, to fund their programs, to provide opportunities. And this is what we're trying to do, is just open up that aperture. So currently, right now, there are 49 advanced manufacturing IP schools in Massachusetts. We've streamlined the designation process to make that go quicker. We're aggressively looking to move to 65 schools in the next academic year, and we believe this will result in generating more talent to help the workforce pipeline. At the same time, we needed supports. And so one of the supports that we created, I'm running a session on this later, is a DoD-funded curriculum. It was a 10-hour curriculum that has kind of blown up. We launched officially in March. We have 1,700 students slated to use it in the fall. The Executive Office of Education for Massachusetts has adopted this as a go-forward. So if you want a quick pathway to designation for these programs, using this and one of the other one of the other curriculums out there will help you get that designation really quick. The other piece, which is really fantastic, is students also have to do 100 hours of work-based learning, either through an internship or through some sort of capstone simulated experience working with our workforce development boards. So this right here is just a really quick commercial for this curriculum.
I want to introduce you to the world of high-tech manufacturing. You may know exactly what you want to do in 20 years, but you may also still be searching for a career path. In this course, we'll learn about areas like robotics and 3D printing, flexible hybrid electronics, photonics, and functional fabrics. My goal is to introduce you to some exciting possibilities in Massachusetts and across the country. What does it take to manufacture this new technology? Let's take a look.
So we're now set up. If anybody in this room is an educator and would like to use this curriculum, if you use Google Classroom, we have it set up for a Google Classroom. I'll gladly share with anybody. It's free of charge. We just want to help share this with folks. Another support that we're doing is a mashup. We have this huge conference. It's at a baseball park. It's lots of fun. We had 1,200 attendants last year. All of our state legislators come to provide awards to different manufacturers. We had 300 of these advanced manufacturing students come in, got to touch and feel the coolest technology in photonics and robotics and be exposed, because it's about exposure to these careers in order for them to see themselves in these careers. So we have 300 students participate in design engineering challenges and lean manufacturing challenges. Grants were given out, and it was to create excitement and awareness to an industry that they knew nothing about. And then lastly, 15 seconds. We're doing stuff with the community college. It's great. I could talk to you more about that later. And then I think the biggest piece that we're trying to do is around creating awareness through marketing. And so we've done a statewide campaign. We have billboards. We're in check cashing places. We're at hockey rinks. We're all over in different places. And the idea is, with our brand MASSMakes, is we want to expose students to careers that are there. We built a website that they can get all this to. And this is sort of
what gets you up in the morning? What makes you tick? What do you find interesting? If you like to create things, make things, build things, use your hands, you can flip that into a future. You can turn that into a career, all while making a difference. Find out how at MASSMakes.
I know you could do it. All you gotta do is put your mind to it.
If anyone's interested, I can get you posters and things like that too that we're doing. But one decision can move rivers, and you are the folks in this room, the leaders in STEM, that can actually make those change and make that impact. So thank you for your time.